Hello guys, welcome to my channel. In today's video, I would like us to talk about level measurement and density measurement using radiation. But before we get to the topic, I'd just like to talk about two important things. The first important one is that the radiation source that is being used in this video, it's not a real source, it's just for display. It is not radioactive. Otherwise, if it was radioactive, I was not going to come this close to it, because there are safety concerns that are relating to radiation, and that guides how close a human being should be to radiation. As you can see on this side, it's written empty, so it's just an empty source. It does not contain a radioactive source. It's just the source container only. The second thing I would like to talk about is please subscribe to the channel so that the channel can grow, so that we can continue sharing important information about instrumentation, control, and automation. Okay, let's get to the topic of the day. Today's topic is level measurement, density measurement using radiation. So, what is radiation? Radiation is a source of energy. It is a type of energy that occurs naturally. You can get radiation coming from sunshine, and there are also other elements, natural elements like uranium and others, that are naturally radioactive, meaning they emit a type of energy that causes radiation. I'm not going to get too much to the technical specifications of the radiation, but the most important thing is that it is a natural source. It can be used for many things, like in power stations to generate electricity. You've heard about nuclear weapons to create weapons, because it's a very large type of energy but can be stored in a very small space. But in instrumentation, it's also used in the hospitals and things like X-rays. It's a type of radiation. And in chemotherapy, when they are treating cancer patients, they use a type of radiation to treat some illnesses. But in instrumentation, we use radiation as a source of energy that we can use to measure levels and to measure density. Let me just explain how this works. So what happens, radiation, because it's a very, I would say, strong type of energy, but it's also invisible, it can penetrate some materials. So there are areas whereby it will be practical, or a more suitable solution to use radiation to measure level and density. Let's just take an example of density. It is very common in the mining industry to have, let's say, a pipe. Inside the pipe, there's a slurry that is flowing, and we are interested to know how much density that slurry is. We know from basics of science that density is mass divided by volume. So if we know the diameter of that pipe and the length, surely we can calculate the volume of the pipe. So we will have at least one variable of the density. But the mass, it won't be practical to put a scale on a pipe to measure how much that material weighs. So we can actually use a radiation source. We place the radiation source on the other side, and then we place a detector. It's actually called a scintillator. We place it on the other side. So then we can detect how much radiation energy is able to pass through the pipe. If the pipe is empty, obviously the radiation energy can pass through with minimum resistance. But the higher the mass of the material flowing inside that pipe, the higher the resistance to the flow of that radiation energy. And then we can use that calculation, or we can use that resistance to the flow of radiation energy to determine our mass. And once we know the mass, and then it's going to be easy then to calculate density from that. So that's just the basic principle of how this instrument works. It will be a similar example for level. So it's going to be a similar example or a similar principle for mass, for level. Let's say you've got a vessel, and then when that vessel is empty, you put the radiation source on one side of the vessel, you put the scintillator on the other side of the vessel. So when the vessel is empty, the amount of radiation that passes from one side of the vessel to the other side is is at maximum, because there's less resistance. Minimum resistance, maximum flow of energy. But then as the level of the vessel goes up, then the amount of radiation that can pass through is minimum and the resistance is higher. Okay, that's just basically the principle that is being used here. Okay, so let's look at the individual components involved in this system. First of all, let's start with the radiation source. So the radiation source will be installed in this, inside the container. This is a source container. It's made of very strong cast iron steel with some lead, because lead is known to be resistive to the flow of radiation energy. There are companies that are manufacturing these source containers, and there are regulations that govern how these source containers should be handled, should be transported, and should be used in the industry until disposal, because we do not want that amount of radiation energy to end up in the wrong place. But like I said, this source is empty. This container is empty. There's no source, but I'm not going to turn it around. But it's just empty. It's a dummy source. But on top of here, it's manufactured for Anderson Hauser. And when the source contains something, there will be stamped on that nameplate the amount of the type of the radioactive component, which is a cesium-137 or another type, and also the strength of the source, how strong that radiation source is. So that's how it works. So it's got a shutter, if you can see. It's currently closed. When it's being installed, obviously we're gonna open it. Once we open, it's gonna open, meaning allowing the radiation to flow through. But in storage, it's gonna be kept in this closed position and probably locked here. Okay, so that is the source container. This is how it looks. It's round. It can be mounted using brackets on the flange, and it's usually gonna be mounted on the other side of the pipe if we are measuring the density of the pipe, or on the other side of a vessel if you are measuring the level of the vessel. Then you get this device. The second device is called the scintillator or radiation detector. This one is coming from Vega. It's called the Vega Minitrack 31. We will have a separate video that shows you how to set the parameters and how to do the calibration. For now, we're just introducing you to the components. So this is just telling you the power rating, how much power it needs to be powered, and how much, and the output that you're getting is a 4 to 20 milliamp hour. This side, you're probably going to have a display, something called a PleaseCom. Install it there, and then you can set the parameters. You can actually connect the wiring as well there. And the other side is usually power. Okay. This side, we have the same device, it's also called a scintillator. It's coming from Anderson Hauser. As you can see, it's very long, and it's actually nicer to, you can actually mount this one, I would say, vertically up, and then the source is on the other side, so throughout this length. It's also got its own specification, the amount of voltage you can use to supply it, and the milliamp output, and so on. Most of the time, this one will not come built in with its own display, so there will be a cable connected between this point and that Anderson Hauser display. That Anderson Hauser is just a generic display. It can be used for a number of Anderson Hauser instruments. Okay, I hope I did explain the components clearly. So usually the scintillator has got electronic components here that can detect radioactivity. So like I said, the source is going to be emitting the radiation. This side we're going to be detecting. And then the amount of radioactivity that we detect this size depends on the resistance or the density of the material or the medium in between. This one is usually used like, let me put like this, it's going to be facing like that. So if you look at your density, the radiation source is going to be facing this way, and then my detector is going to be this side. So the detector is actually here. So it's going to be facing directly the source. Okay. Yeah, I think I've covered the most important components of the video. We're going to create another video where we take one of the two. We're gonna take the Mini 331, which is the Instrumentation, go through the parameters individually, and then also gonna do a separate video for the Instrumentation. Okay, but that's how density can be used. One of the interview questions that I've been asked, and in one of my interviews, was how can you measure density in a slurry or in the pipeline? Before I came to understand density measurement, I actually thought that, okay, the only way to measure density is to know mass, meaning we will need something like a scale, until I got exposed to this type. As technology advances, there have been other type of density sources that are not using radiation. Some of them are ultrasonic, others are using other different principles, but this is just one of the ways you can measure level and density using radiation. Thank you so much for watching the video. Please do like the video, share the video with people who will find it beneficial, and also please don't forget to leave a comment and subscribe to the channel. Thank you so much. Enjoy your day. Goodbye.